We're going to talk about right-hand sums. The simplest case is if we do it for functions defined over the interval 0, 1, and we'll only look at equally spaced intervals. This is what a right-hand sum looks like. It looks like the sum I equals 1 to n of f of I over n times 1 over n. This is the sum of the areas of boxes. This will be the height of the box, f of I over n. 1 over n will be the width of the box. Let's look at an example to see how this sum works. Suppose we have y equals x squared plus 1 and n equals 4. That's going to correspond to a picture that looks like this. This is y equals x squared plus 1. We're looking at it on the interval 0, 1 because we're only going to look at a right-hand sum on 0, 1. And since n equals 4, we drew 4 boxes. And notice that each of the boxes has width 1/4. We took 1, we divided it into 4 pieces, so each of the widths was 1/4. And to get the height of each box, we look at the right of the box. So we go to the right of the box and we evaluate the function at the right side of the box. So the right side of the first box is 1/4, so we'll evaluate that at f of 1/4, and then we'll evaluate the next one at f of 1/2, f of 3/4, and f of 1. That's what this sum is going to be. So let's take a look at it. The function f of x is just x squared plus 1, and our sum here is going to be what we get when we put in n equals 4. So we have the sum, I equals 1 to 4 of f of I over 4 times 1 over 4. That's our sum. Let's write that out using what we know about summation notation. So when I equals 1, we get f of 1 over 4 times 1 over 4. When I equals 2, we get f of 2 over 4, which is the same as f of 1/2 times 1 over 4. When I equals 3, we get f of 3 over 4 times 1 over 4. And when I is 4, we get f of 4 over 4, which is the same as f of 1 times 1 over 4. And this sum is exactly the sums of the areas of these boxes. Again, the first box has height f of 1/4 because we use the right-hand endpoint for the right-hand sum. So we go to the right, take f of 1/4 times 1/4. And then for the next box, that's this second box, we look to the right, we take the right-hand endpoint. The right-hand endpoint right there is 1/2. F of 1/2 is this height. F of 1/2 times 1/4 is the area of that rectangle. For the third one, we look to the right. Right-hand endpoint is 3/4. We substitute 3/4 into the function to get the height. That's this height. That's the height of our box. F of 3/4 times 1/4 is the area of that rectangle. And then for the last one, we go to the right again. F of 1 times 1/4 is the area of that. So that sum of those 4 boxes, of the areas of those 4 boxes, looks like this. And we can calculate it and figure out what the number is just by using this function. So we take f of 1/4. That means we need 1/4 squared plus 1. So in for f of 1/4, we put 1/4 squared plus 1 times 1/4. In for f of 1/2 times 1/4, it's going to be 1/2 squared plus 1 times 1/4. In for f of 3/4 times 1/4, it's going to be 3/4 squared plus 1 times 1/4. And for f of 1 times 1/4, it's going to be 1 squared plus 1 times 1/4. Do all that arithmetic, multiply all that together, we got 47 over 32. That's the sum of the areas of these rectangles. That illustrates this general right-hand sum. You would do the same thing if n was equal to 50 instead of n equals 4. If you had 50, you'd have to write out 50 terms, and you'd have 50 boxes, but the exact same pattern would apply. You'd have 1 over 50, 1 over 50, 2 over 50, 3 over 50, and so on. And then you get a much longer sum to compute. But that's the idea of right-hand sums.